Hello student, let us start the first lecture series of analysis of structures. So student, this is the first lecture. So before start my lectures, we will try to understand what are the learning outcomes. So first of all, we learn the different methods of analysis of structure. Then we compare between these methods with the other methods, and finally we will understand the displacement method very well. For the structural analysis methods, the methods are force methods, displacement methods and approximate methods. Now in force methods, there are four types of methods, that is methods of consistent deformation, where the deformation is very important term. After then, the theorem of least work, column analogy method and flexibility method. Now, in the displacement method, the slope deflection method, moment distribution method and Kani's methods. As well as the stiffness methods also we will learn. For approximate methods, there are three methods, portal methods, cantilever method and point of inflection method. Now for this today's lectures, we will focus only on the displacement methods and slope deflection method. Now what is slope deflection method? Now this method is developed by Axel Bendixen in Germany in 1914. Now in this method, the displacement method, where the displacement taken as an unknown and which is obtained by solving equation of equilibrium. Now this method is completely for the indeterminate structure, where the degree of freedom is more than 1 or 2, where that unknowns is the displacement. Now this is the classical method, which involves number of equations connecting slopes and moments at various points of beams or frames. It provides the excellent background of the study of a moment distribution method. These methods provide to matrix method of structural analysis. Now in the next lecture series, the stiffness methods we will try to understand, and this is the basic of that matrix method. That matrix is developed by the slope deflection equation. Now this methods enables us to sketch the deformed shape of the structure. Now let us try to understand the assumption in slope deflection method. In this method, the beam is having constant section between each pair of support. All the joints of the frame we assume as a rigid. Then distortion due to the axial and the shear stresses being very small, hence we can neglect. The joint in the structure as a whole may rotate or deflect, but angle between the members meeting at the joint remains the same. Now the application of slope deflection method, the continuous beam as well as the frames. Now in frame sway and without sway or a non-sway frame also we will analysis. Now let us start the slope deflection equation. Now here this is the formula which comes under the small derivation. Now in this today's lectures we will just try to understand the equation of final bending moments or the final end moments is equal to fixed end moment due to the external loading plus moment due to the rotation plus moment due to the deflection at that end. Using appropriate equations of equilibrium at the joint along with the slope and deflection equation, for each member we obtain a set of simultaneous equation with displacement as a unknowns. After evaluating displacement, the end moments can be computed using slope deflection equation. Now before start the derivation, you must know all the formulas for various types of the beams and the loading conditions, okay, for end moments and the free end moments. Now these are the different beams the loading different loading conditions, like we can say the UDL, point load, eccentric load, varying load, okay, and the moment also, and the cantilever beam. So you can take the screenshot for this formulae, which will help in next equations. So thank you very much for the today's lectures. From the next lecture number 2 for this series, we will try to understand a small derivation which will clear the equation of slope deflection. Okay, thank you.